So today's lesson is a continuation of last time, and we will.
That's not the very shiny.
We will be looking at some more introduction to Python scripting. I'm going to mute everybody. If you have a question, unmute yourself and ask the question, and or type the question in the chat box. Probably best to do both if you can remember to. So first, let's see, mute everybody. Okay. Current and new participants will be muted. Yeah, that's what I said. And if you have a question, unmute yourself. Next thing I'll do is, see, I got the recorder running. So I will share my screen. And there we go. It goes there. And today's lesson, boy, I hope this link works, is on a topic called data structures and control statements. And by data structures, we mean a couple of different ways variables can be gathered or grouped within a program to accomplish a task. Conditional statements are really pretty much for program flow control, and they are if true, then do something, if false, then do something else. And so that's what's meant by the two. I'm going to prepare some other things here because I will attempt, although I may fail, to be able to demonstrate some stuff as I'm talking. There's our friend CoCalc, and then let's see, I've got to get one more thing going. I'm going to take a sneaky route here. Let me get another tab open. Oh, I thought I had left. Oh, I failed, didn't I? You have no idea that I failed, but I know I failed. Lab 3. Okay, I didn't have up and running what I thought I did. Oh, that bar is going to annoy me. There's the chat. Yes, you did use simple conditionals in Lab 2, and now we'll show you how to do it. So if you figured it out, you're good to go. All right, so let me work through the lesson. So there's really only two topics in this lesson: data structures and conditional statements. And the objectives is so that at the end of this you'll understand, or at least have been introduced to different data structures available in the programming environment that are helpful for handling data, and to implement the concept of decisions in Python using conditional statements. That bullet item is probably not the best English sentence for what it really means. So recall our computational thinking concepts from our last couple lessons. Remember that the concepts were abstraction, decomposition, and so forth. And so data representation, in one sense, is a type of decomposition, and then interpreting that data by analysis and various toolkits is decomposition. And then conditional statements themselves are decomposing a problem and towards the end goal of algorithm design. So the data structures available in primitive Python, so that's without any special packages, are lists, tuples, sets, and dictionaries. And arrays occur when we use the NumPy package. As far as I know, a list and an array are quite similar. What we're going to examine today are lists, a little bit on tuples and dictionaries, and these are just names for particular data structures. We'll also talk about sets. And these names were given to these data structures in an effort to associate them with their meaning in other forms of engineering mathematics. So a set in Python has a lot of properties of a set in mathematics, and so forth. So an array is a structure that can store elements of a specific data type. So an array can be an array of floats, an array of integers, an array of Boolean variables, logical variables, and so on. But generally arrays don't have mixed types. So if we had an array that had 3 integers in it, 1, 2, and 3, the array itself could have a name, and then each element of the array associates with a location somewhere in the physical computer memory, and the contents of that elements would be the 1, the 2, and the 3. If we had a situation where we had a collection of things such as 1, 2, 3, Fred, and David, and otherwise unrelated, if we put that into a structure, that structure is called a list. Lists can have different element types. Arrays don't. Arrays are ordered, which means that the information is stored in an array register, and it's has a specific location relative to the beginning of the array. So that 1, 2, 3, the second element of the array, starting counting from 0, has the contents 3. I have a picture coming up that will explain this a little better. Mutable is a fancy word meaning that you can change the contents of an array. So we can literally specify the name of an array, a specific index in the array, and assign a value into that, and it will replace what's ever there. If that specific index is outside the current defined array range, so if an array has 3 elements and we try to assign something to the 4th one, direct assignment won't work, but there is a method called the append method, which is built in, and we can append to an array, and it adds that additional component at the next position. So here's a visual representation of an array. What's missing from this representation is the name of the array. And let's go to a slightly different...
Dr. Cleveland?
Yes?
Excuse me. Hunter emailed and said that he's waiting to join the Zoom meeting, but you still haven't let him in.
Oh, and a few other people. Thank you, Hunter. So these two pictures are essentially the same thing. The one missing from this picture right here is the name of the array. So Fred, David, Judy, or the always intelligible my array or my list. And then the contents of the list occur in different locations. Then the index associates the location with the particular content. And here are the index positions. This line is reverse indexing, which is kind of unique to Python-like languages, in that it counts from the beginning to the end, or from the end to the beginning. It has some advantages when these get really long. And then the contents, in this case, are shown here. So if this array is called my array index 2 has a content of 4. So quick quiz, it's freebie because they're not going to grade it. What would the result be if you had it print my array index 4 be? Anybody? Okay, so we got a 16, good. Whoever entered the 8, that's incorrect. You missed it by 1. So index 4 is this guy right here, and it has contents of 16. Very good. Yes, that's right, Max, because 1 is 0. Welcome to Python. Good is bad, old is new, 1 is 0, like that. So the data type of the array is specified using a type code. So there's float, double, integer, and cap I for unsigned integer. To use an array, we have to use the library, which is the array library. And we're going to save arrays. Actually, the demos are done later in the course. Other than introducing an array, we won't see them just yet. And not put off too long, maybe next week or two. Second type of creature is called a list. A list is an awful lot like an array. They can be used to store elements of different data types. The lists are indexed, they're immutable, and if you want to perform arithmetic, you have to perform operations on each element of the list. The elements of the list are enclosed in a square bracket, and here's an example of some lists. So my list 1 has 2.3, 4.6, 6.9, 54, and 1001 in it. Let me go ahead and bring my CoCalc thing up and running and create a new project, and we'll just call this lesson 3 project. So all I want to do is have a, not chemo, demo. There we go. An open notebook that I can try some of these things out. And so as Tom Petty and the Heartbreakers say, the waiting is the hardest part. So we'll create a new worksheet. And Jupyter. Sure, Python 3. Yay! It didn't work. There we go. It is running a little slow today. That's not a huge surprise. So let's, I don't think I can cut, yeah, I can't cut and paste this, so I'll have to type it. Let's we'll start with this my list and we'll just start building on it. So let me look at the first one, 2, 3, 4, 6, 6, 9. Let's go ahead and create my list. This is just to watch, so if you don't need to follow along if you don't want to, or if I'm going too fast. So we'll just create an element 2.3, 4.5, 6, Fred, Judy, (2001). Okay, so now we've created it, and name my list. Maybe we should do it right. So let's try that again. Okay, and a winner again. And if I look at the contents of my list, it returns what I put in. Let's see what the type my list is. It's a list. Pretty smart machine there. We can also have lists of lists, and that's a fairly important concept. So a lot of engineering programming can be done on lists of lists, or you can use the array structure, which is a little easier. So a tuple is very similar looking to a list. It has contents, it has elements, but it's immutable. Once a tuple is created, its contents cannot be changed. So that has values for things that don't change. So you could have a tuple called the months, and you go ahead and create a tuple. And the sneaky difference is it's done with a ordinary parentheses. And so on. So this is a 4-month year. So that's, it's like on Mercury or something. And so if we do the type,
Dr. Cleveland, can you please check if there are other students in the waiting room?
sure.
Thank you.
And it tells me it's a tuple. So it knows that from the way I defined it. So now let's see one example of the difference. What I'm going to do is I'm going to take the my list object, and let's take the third component of it. So my list of 2, it should be a 6. Let's verify that. It is. Let's now make it some other value. 66, because we get our kicks on that. Now if we type my list, element 2, it's a 66. We'll now try the same for months. I think the syntax is, I'm going to find out because I actually haven't done this in a week. Okay, that's not the right syntax. And yeah, it's gone into screw up mode because it's a computer. That's not what I typed. A little bit of correction here. Okay, so the third item in months is March. Let's go ahead and attempt to change that. And we will even adhere to the variable type. Make it May. And it comes back with this message that says the tuple object does not support item assignment. That's its fancy way of saying we can't change the contents of that. So tuples are lists, essentially lists that are used for things that are not going to change. Probably at this stage, if you're really new to this stuff, it makes no sense why you might want to have that. But it has value for static things. So like months and things, there are items that you encounter in your computational life that are static in nature, and a tuple might be a good tool for that because it doesn't have to, it can be in contiguous memory in the computer. So just a quick look at the chat. All these things I'm using are actually in the online document at the data 8, where it explains tuples and so forth. But in this chat, a tuple has the round brackets, a list has the square brackets. But we're not done yet, because now we're going to use the curly brackets, because there's a key for them. And so, it'd be stupid not to use a key, be inefficient. Tuples can be nested, so they have almost all the properties of a list, except you can't change their content once they're created. A set is a little different. It's used to store elements of different data types. Sets are not ordered in any sense. If you're familiar with other languages, a set and a hash are very much the same thing. The elements in a set can be altered, and the key thing is the elements are unique. So if you have a set comprised of the numbers 2, 3, 4, and 5, there's only one 2 in that set, one 3 in that set, one 4, and one 5. Sets are created by enclosing elements in curly brackets, and here's a couple examples here on the screen. Sets are not nestable, so they can't be nested. So my set 2, for instance, has 3 numerical values and 2 strings in it. Last kind of tool is called a dictionary. Funny name, but it's actually a pretty interesting object. So a dictionary, you can imagine it as a list. If you imagine a list, so the items in a list are identified by their position. So they're indexed, the 0, the 1, the 2, the 3. Another way to think of that is that position is just a key. It says if I pass to a particular list the key 2, it goes and it finds the third position in that list and gives me the contents. But what a dictionary does is it takes that conceptualization one step further and provides the ability to include a key in input. So a dictionary, the elements are changeable, but the keys are not changeable. And let's look at a diagram of it. So here's a dictionary. I mean, it looks almost like a set because of the curly bracket, except for this peculiar syntax where there's an object, a colon sign, another object, and a comma. So what this is the key for this first object is name, and the content is Joe. So you could have a dictionary with many different names. There's only one grouping called name, but it could be Joe, Fred, David, and so forth. And then age, colon, 8. Here the key is age, and the value is 8. Class, colon, second. The key is class, the value is second. Here's one for cars. This is a pretty classic example. Brand, Ford, model, Mustang, year, 2020. And you can have nested dictionaries within a dictionary. And I think we have some examples of dictionaries in Lab 2, so I'm going to pass on the demo to move on to conditional statements. Okay, so before I move to conditional statements, the key things for this first part is we're not constrained to variables that have a name and are just one thing. So that variable name can be a list, which can have a lot of things in it. It can be a dictionary, which has a lot of things in it. It can be a tuple, which has a lot of things in it. And that's not a trivial utility. If we want to look at a variable such as a vector, if you will, it's a whole lot easier to refer to a variable as mylist position 1 has contents of 11 rather than mylist 0, a single name, mylist 1, a different name, mylist 2, another different name, and so on. It's far easier to express a variable like this. And so the mylist variable has 1, 2, 3, 4, 5, 6, 7, 8 items in this particular example that I have on the screen. I don't want to scroll up too far. This is your lab, and I'm not afraid of you looking at your lab. It just would confuse the issue. And so if I want to refer to 13, 1, 2, 3, 4, that would be mylist 4. And I can use that in arithmetic as needed. And that's the power of lists and so forth. Okay, conditional statements. These are statements that are used to test a condition, and a decision is really the wrong word, and then make a and then proceed forward based on the result of that test. And it's used for flow control in programs. I think I'm safe in saying that all practically useful programs have some flow control via conditional statements in them. When you go to your Amazon account, there's plenty of conditional statements going in. You know, did the sucker buy something last time? Was it cheap? Maybe we should offer him a few more of them. That's all deep hidden away in the computer program, a collection of conditional statements. And they have more efficient ways to do it at that scale. So the statements in Python are if statements, inline if, and then an if, what I call block if statements. So there's a block of if one thing, do something, and then if something else, do something. And then there's the if, else statements. So these are even bigger blocks. We'll look at them one at a time. So the if statement is used to test whether a particular condition is true or not. And then based on the result of that test, we can continue operations based on the result of that test. So as you're entering the conditional, the condition has to be something that can be logically evaluated. So if you recall last time in operators, we had the, for example, we had variable A less than equal to variable B. If we type that, we would get a true or a false. Let's go ahead and do that as an example so it's makes sense. Let's set A equal to 3. Good, it actually listened to me. We'll set B equal to 4. And we'll just test if B is less than or equal to A. And that test is false. So that's what's meant by a condition, something that can be tested as true or false. We can try a different test. We can see if they're the same. Also false. And I'm not sure that's the right syntax, but let's see what happens. True. So those are the, that's what's meant by a conditional. So the condition is that B greater than or equal to A. If the result of the test is a true, then we can have a part of the script we want executed. And if the result is false, it skips this portion of script. And here's an example of how it's implemented. two important things are the colon, because that's identifying what's to be executed if the condition evaluates as true, and then these statements themselves. We'll do an example back on CoCal in a second. The indentation is vital, because indentation is what the Python program uses as a delimiter, or a scope, as a scoping delimiter. Other computer programming languages use square brackets, curly brackets, dollar signs, backslashes, whatever the designers chose as scoping delimiters. The Python designers chose to use indentation as scoping delimiters. If you're an experienced programmer in other languages, initially it's quite confusing. If this is new for you, since you've never had another kind, this should actually come in kind of naturally. You just keep everything grouped by indentation. Now when the grouping gets kind of deep, no, Braden, you don't need to put the less than greater than. So actually that brings up a good question, other than my smart aleck answer. So this less than, greater than, and then something in here is a kind of computer jargon. It's like quotes. So stuff goes in here, but you don't include these end pieces. It's just a way of writing a pseudocode. So let's go ahead and go back here and we'll work on our conditional. We'll leave A and B as they were, and we'll go ahead and we'll do if A less than B, we'll put the colon. So what's going to happen here is it's going to evaluate the expression A less than B. If the result of that expression is true, it's going to do what we tell it next, which is, we're going to do something stupid here. We'll just have it print A is. And that's our conditional. And let's go ahead and so this last part is just icing on the cake. Hopefully I did that right. So here's what should happen. A is 3, B is 4. So is A less than B? Yep. So because that's true, it's going to print to the console A is less than B, and then it's going to print test complete. Now we will run it. Sure enough, A is less than B. Now let's go ahead and make that no longer true. I'll run it again, and it skipped that because that section in the indentation was false. So that's pretty useful, but what's more useful would be to be able to execute. What would be more useful is to be able to execute multiple conditions, and we'll see how to do that next. So we've actually kind of just done the equivalent of this demo. But let's look at what we have on the screen here and see if we can figure it out without actually running it. So if 100 is greater than 200, that's false, so nothing happens. If 100 is...
I think somebody's in the waiting room.
Nope.
Okay.
If 100 is smaller than 200, that's true. It's going to print smaller. And there's the example. So the if-else statement is a natural extension of just the inline if, where we start, we test the condition. If the condition's true, we execute a set of statements. If the condition's false, we execute a different set of statements, and then we get back to the end of the structure. So let's go back to the one we've already started. And if A equals B, actually make sure I remember the syntax, because I actually don't. If else, yeah. And then at this level we put the else. And these examples are intended to be almost ridiculously simple. These single lines, these print statements, those could be dozens of lines of actual code in a useful program. So here we go. Let's run this one. Let's see. A is not less than B, test complete. So let's go ahead and make A less than B. And okay, so that's the if-else structure. So everything in the if structure is what's ever contained in that I'm going to just put a bunch of lines to indicate what I show you what I mean by it's not just a single it's auto-indenting, which is a rather annoying feature when you don't want it to happen. But it's pretty handy when you do want it to happen. So that's life. Okay, so that's what, 7 different statements. I mean, they're all just print statements. And here we'll just say it's not less than B. So now if we run our program, and we can get some significant behavior. And that's the if-else structure. So we actually just did that. So if condition, statements, else, more statements. And so here we have if Bob in the list. So what this statement is saying, does this list, Sam, Bob, Mary, Joe, contain the string Bob? If that's true, print present. If it's not true, print absent. So what this would do would print the word present, because Bob is actually the second element, position 1 of the list. Now if we have multiple conditions, it's very much like an if-else structure, with the addition that we can have intermediate components to the structure. And it's done if condition, set of statements, if a different condition, set of statements, and then the mutually exclusive one is what's left. So let's go back to our example, and we're going to do this if-elif structure. Make sure I get the syntax right. So we'll test for less than, equal, and greater than. Okay, so there's our set up. Tidy it up a little bit. All right, so let's examine what's going on. If A is smaller than B, it's going to print A is less than B. If A is equal to B, it's going to print A is equal to B. And if A is greater than B, it's going to print A is greater than B. And we left this last one as the else. There's another way to do this that you might encounter when you're maintaining other people's programs. And let's run this one first and get a good feel for it. So A is currently greater than B. Kill off that second 3, so A should be smaller than B. A is less than B, and let's go ahead and test for the equality. A is equal to B. So there is the if, elif, else statement. So another way to do this exact operation, it seems dumb, but I think it's worth doing it. So we test for greater as an explicit if test. We'll go ahead and put the print statement there. And then in the else block, this is where we do error trapping. If somehow it can't satisfy those 3, we can trap the error. And in building commercial codes, you see a lot of this. And there's no way to get to here, but you put like a label so it's easy to find what part of the 2 million lines of code is broken. So when I run this again, there's no way we'll ever get that last print statement. I don't think I can come up with a less than B test that would do it. Although I guess I could try mixing
Put a hashtag.
I could try different variable type, but I'd probably get an error. So anyway, that's another way to accomplish the same thing. So let's do A is greater than B. And so that's the if, else, elif, else structure. It's a matter of personal preference if you want to explicitly test, in this case, the last case, and then include the else part or not. As you're just starting out, you probably don't want to get this fancy. You probably just want to get it to work, and that's perfectly fine. I really should look at these things ahead of time, because that's exactly the exercise we just did. It's also possible to nest statements. So you can have an outer condition, and then within one of the conditions you can have subconditions and evaluate them. And that's very common. I would demonstrate, but I can't even think off the top of my head a quick one that makes sense. So we'll save that for lab. And to summarize, so we look at different data structures in Python. And the ones we looked at, I seriously wish I could get that out of the way. Put it down there. There we go. The ones we looked at are lists, tuples, dictionaries in particular. We addressed an array, but an array is a special feature of the NumPy, the array package, which is part of NumPy, which will be saved for later. We haven't talked about packages at all yet, although I was going to actually get to that a little bit today, and we'll do it here after I finish the summary. And then we looked at the concepts of conditional statements in Python. So the conditional statements are block if structures. So if a condition is true, then execute a set of statements. If the condition is not true, execute a different set of statements. That's the if-else structure. Then there's a straight inline if, which is just if true, then. And indentation is used to delimit the scope of the statements that are executed after an if statement. The colon is used at the end of the condition statement to identify the next upcoming block of conditions to be executed. Oh, that's a good question, Braden. We actually haven't talked about the logical structures of and or, and not. I'm not sure if I actually covered that in the lab. We'll take a quick look. Yeah, the lab covers logical operators. So, Braden, just wait, and we'll be there in a minute. Okay, so we're going to take a 5-minute segue here, or tangent, or whatever you call it. So that's when your professors go kind of crazy and do stuff that doesn't make sense, but I have a reason for this. See if I can get a picture of a TI-55 calculator. Yeah, that'll work. That's what I want. Okay. So I'm going to make my first attempt at explaining modules and functions. This may be a complete failure, so if it baffles you, immediately wipe it from your brain. So here's a picture of a calculator. And down here are the number keys, and if we want to multiply 2 and 3, we'd press the 2, we'd press the times button, we'd press 3 and press equal, and it would return a 6 up here in the output. So that's an ordinary calculator. There's a whole section of stuff up here, which is part of the calculator, but it's not part of ordinary arithmetic. So if we want to use any of these keys up here that are blue, or the fix, the ENG, the gallons and liters, pounds and kilograms, we have to press this key here. It's called the second key, or the function key, and then we press one of these to get this second function that's assigned to that button. So Python, all programming tools have a fairly similar concept in that there is components that aren't part of the ordinary arithmetic down here, and they're accessed by telling to the program, go out to my library somewhere and load in one of these special keys. And then once it's loaded in, we can use the key. And that's the import keyword that you see at the top of a lot of scripts. So let me go back to my lab 3. So up here, this is my lab 3. This stuff is for me. You see this thing right here? It says import system. So import system is the Python equivalent of press the second button and press the key that gives me system commands. And what import system does in this case is it enables certain commands to be sent to the operating system and recovered. So the first one I'm sending is tell me what the executable path is for wherever this spreadsheet's operating. Tell me the version number, and then tell me the version information. So it returns the executable path is optional environments, Python, bin Python. It's using version 3.8.3, installed July 2nd, 2020 at 4:21 in the afternoon. And it was compiled using GCC compiler 7.3.0. And it's a major install. This is the 3.8.3 release level final, serial number 0, which means it was free. These other two, this sign here is actually not part of the system install. Those are Jupyter notebook things. And it's actually asking what's the name of the computer this is running on and who is the computer user. So this is running on a computer named atomickitty.aws. So that's a Amazon server, and the user ID is a comp thing. So this import system is the functional equivalent of pressing the second key and then selecting particular commands that are now available once the second key's been pressed. Later on, not this week, I believe next week, we introduce functions and modules, and that's all that's happening with the functions and the modules. And if you install the wrong module, you don't have access to the keys you think you do. If you attempt to install a module that's not available, it can't install, and it'll tell you. Okay, so that was actually as tangents go, that one wasn't bad. So I'm going to get rid of that. I got my CoCalc up and running. So that pretty much completes what I had intended for the lesson, for lesson number 3. And now we want to move over to lab. So what I'd like to do is take a 10-minute break. What I would suggest is I'm going to pause the recording for 10 minutes, start up again, and then we'll introduce the lab, and Farhang is going to pretty much lead the lab. I'll do a few minutes of introduction, and then I'll get out of the way. So before I take the 10-minute break, does anyone have any questions? Anybody still there? Ah, okay, good. You're still there. All right, so we're going to take a 10-minute break. I wish I could say it in German. It would be actually 5 minutes would be 5 Minuten Pauses, but I can't remember how to spell any of those. I don't think I'm here. Ah, thank you. 10 Minuten Pauses. So I'm going to pause the video.